All right, welcome everybody. We are going to go through solving quadratics by factoring. The thing about this lesson is that if you are a solid factorer, you're going to feel like this is the easiest thing we've learned all year because it's literally just factoring. There's almost nothing more to this work than factoring. If you look at these steps here at the top, solving quadratics by factoring, it says move all terms to one side and set equal to 0. Okay, moving all terms to one side, to move a term to the other side of an equal sign, if we wanted to move this plus 9, it's as simple as going minus 9x, and then from here, we're just moving one thing to the other side, and that's it. And that's an Algebra 1 skill, so that doesn't really make us too nervous. Welcome, Mr. White. Good to see you. Step 2 is factor. Like I said, most of this stuff is factoring. And so if you're good at factoring, then we're kind of feeling pretty good. And then step 3 is really the only thing we've never seen before. Set each factor equal to 0 and solve. And we'll see when we get there how easy that is. Step 4 just says write your answer. So step 4 hardly even counts as a step as it is. Now, before we started these notes, for number 1, I was already talking with class and we were able to come up with 2 answers that would work. One thing that we talked about is when it comes to quadratics, we're talking about x squared, and basically whatever your highest exponent is how many answers you can expect to have. So we have x squared, we're expecting to have 2 answers. We were able to find these 2 just by kind of looking at this and guessing, and we were just having a bit of fun before lunch. 0 plus 0 equals 0, so we like this answer of 0, and also our negative 9. Took us a little bit more time to find, but negative 9 squared is 81, 9 times negative 9 is negative 81, and so those 2 cancel out and we get 0. So we like these 2 answers. Again, we found them just by kind of guessing and checking, and we'll find out, we'll see later on why that's not really a good strategy long term, but short term, it worked okay. Okay, now we are working with equal signs now, and so these answers should be numbers that we can plug in to both x's. Make sure you get them into both those x's and they work. Now, how do we solve this without just guessing and checking? Obviously, you have these 4 steps up here. So step 1, move everything to one side equal to 0. So we can see here, everything's over here equal to 0. Step 1 is already done. So we're cruising along. Step 2 is factor. Like I said, if you're good at factoring, this will be pretty easy. So step 2, we need to do factoring. Quick review of factoring. Basically, you need to remember there is difference of squares factoring. That would be like if you had x squared minus 9 and you would factor that into x plus 3, x minus 3. Okay, you need to keep that in mind. There's also GCF, okay, and GCF is whenever you have multiple things in common and you're undistributing something they have in common, you're factoring out something you have in common. So something like 5x squared plus 10x is GCF, right? They both have 5s we can factor out. They both have x's we can cancel or we can factor out. And then we have trinomial factoring, which is the regular type of factoring we're used to, which looks like this, where we have x squared, x, no x. So we have these 3 different types of things. Sorry I wrote them diagonally, but I'm sure you guys can handle it. And we want to kind of keep all 3 of these in mind because we might have to do any of these 3, perhaps more than one of them, but don't think that every single question will be a trinomial factoring. That's just not the case. So looking at this, let me make some more room here. I'll go ahead and erase this stuff. Looking at the number 1 that we have, my go-to is I like to see, is it a trinomial? And that's easy because basically, do we have 3 terms? We have x squared, x, and then this doesn't really count because that's on the other side of our equal sign. And so we only have 2 terms, so it can't be trinomial. It's not going to be difference of squares because we have a plus and we have this x, which is not a perfect square. So those 2 things tell me it's not difference of squares. And so it's going to have to be GCF. So people in class, what are we going to GCF? What are we going to undistribute here? Can't be a 9 because this one has a 9, but this one doesn't. Right, here, just an x. So we're taking out an x. We're left over with x plus 9 equals 0. So again, that's just factoring. That is something we've learned 2 weeks ago. and we've been doing for 2 weeks in the meantime. Now, once we get this far, here's where the real kind of math magic is going to happen here, okay? We're going to do a very kind of programmer move strategy, and we're going to say if these two things, okay, let's call that first one A and this second one B, and these are multiplied. If A times B equals 0, what do we know? This is pretty high IQ here. A times B equals 0. What has to be true? Yes, of course, that they both equal 0. But if A times B equals 0, would you agree that one of them has to be 0? Right? You can't take two numbers, multiply them together and get 0 unless one of them is 0. Okay, you can't take 5 and 2, multiply them and make 0. You can't even take something like 1/2 and 2. If you multiply those together, you're going to get 1. So we know that if this is true, either x is 0 or this is 0. Or perhaps both of them, right? You could also have 0 times 0 equals 0. So let's think about this A, just regular old x first. If x is equal to 0, what number would we have to plug in to make that true? And this one's almost too easy to make it kind of weird. Just regular old 0, okay? So let's look at what we have here. We're saying that if x is 0, so if we pretend that this is 0, we've got 0 times 0 plus 9 equals 0, okay? The strategy is we're going to set one of these, just the A, equal to 0, and we're going to totally ignore the second one. And as much as that seems like we're cheating a little bit, the reason it works is because if we can get A to be 0, then who cares what the other one is, right? If A is 0 and B is 10 trillion, it doesn't matter. I mean, it doesn't matter if it's 0 times 5, 0 times 100, 0 times negative pi. I mean, it doesn't matter what it is. 0 times anything equals 0. So as long as we get this answer right here, we're happy because that will make A 0 and we don't even have to think about what B would be. And as you can see, that is an answer that we already knew was true when we were just doing our guessing and checking. So we like that answer. So now if we look at B, the second part, and we say, let me write it correctly, x plus 9 equals 0. And we say, when is B equal to 0? How do we get x by itself? We need to subtract the 9, just like you said. We do a little minus 9 action. Minus 9. X equals negative 9. And now that we do that, we figured out when is B equal to 0. And again, when we're doing this other side, we don't have to worry about A at all. Because if B is 0, it doesn't matter what A is. Because it's, a million times 0 equals 0. So we're good. And so this is our strategy. As you can see, we found these two answers that we had found earlier on using the, reliable strategy of factoring. So we do the factoring. I guess I blocked out the X. Let me undo that. So we do the factoring. We're going to take this one equal to 0. That will tell us one answer, right? This equals 0 gives us 1. We take this equals 0, gives us the second answer. And then that's it. Those are the two answers. We move from there. So I may have even been moving too slow to make that more complicated. Let's move a little faster on number 2. It's very, very, very similar to number 1. Step number 1 on the top of your paper says move all terms to one side, set the equation equal to 0. We should be good, right? Everything's over here, equal to 0 over here. We're good. Just like before, we're going to kind of ignore the 0 for now. We're going to try to factor just this. Are we going to use GCF, difference of squares, or trinomials? Somebody let me know. We're going to use GCF. We're not going to use difference of squares. This is a perfect square. This is a perfect square. This is a difference. So all of this is good. Check, 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 check. But 8, not a perfect square. x, not a perfect square. So we can't use difference of squares. We need to do GCF like Marie said, so we need to undistribute something out. I'll tell you guys it's a 4x that we're taking out because 4 and 8 can both be divided by 4. We have x squared and x coming out. Rachel, you know what's left over once we do that? Easy. So good. And we're feeling great. Okay, we've done the factoring, and now we're just going to use our, our super big brain maneuver here. We're going to think about this as being kind of like two things multiplied together. As long as we can get one of them to be 0, then we have an answer. So we're going to take one of them, equal it to 0, and then solve for x. How do we get x by itself? Divide by 4, and yeah, it doesn't really do anything because 0 divided by 4 is still 0. X equals 0. So there's one of our answers. That was relatively easy, relatively pain-free. And then we're going to take the other factor, and we're going to set that equal to 0. And how do we get x by itself? We're going to add 2 to both sides, plus 2, plus 2. And so we're going to get x equals 2. And those are the two answers. So to recap, all we've done is factor, which we've been doing for weeks, and then this super, super fast step of solving for x. We did literally an adding 2 over here and a dividing by 4, and that was it. Relatively easy. Feel good about that, Maurice? You the man. All right, let's do number 5. So it's the same exact process, but we need a different type of factoring now. Which type of factoring do we need now, Hazel? What are you thinking on this one? Not too tough because we've got 3 parts, and whenever we have 3 things, exactly, we need to do trinomials. So we need to do, here's a refresher, first times last makes positive 21. That means we need same signs. And then we also want to look at the multiples that make 21, right? The factors of 21, right? So that would be 1 times 21, and there's one more. 7 times 3. And then how do we make negative 10 using one of these pairs and using one of these pairs of signs? We're going to want minus, minus, minus 3, minus 7. So the other thing that we need to remember from doing trinomials is we either have to do this, x squared minus 3x minus 7x plus 21, do grouping where we split the 10 into these two numbers that are coming from right here, or we can skip this whole process if we're eligible for the shortcut. So are we eligible to do the shortcut for this question? You guys remember? Okay, so I agree with you, yes, but why is that? There you go. Perfect, right? We want to look out front of the x squared, and if there's no number out here, which technically means there's a 1, but if there's just a 1 out here, then we're able to do the shortcut. Okay, so for right here, there's no number in front of the x squared. That means we can do the shortcut, and that means we take these two numbers, x minus 3, x minus 7, and those are the two factors. We can kind of skip this whole process called grouping and go straight here. So we've done that. That's the old stuff that we were doing 2 weeks ago. Now we need to finish the question. And so what's our next step? Anybody? We need to find the solution. And so up above, once we had our two factors, we need to take A, or we need to take one of them, set it equal to 0, and then take the other one, set it equal to 0. So we're doing the same thing. Taking one of these, x minus 3, putting it equal to 0, taking the other one, x minus 7, and also putting it equal to 0. And remember, we're able to take only one of them at a time, because if this one is 0, it doesn't matter to me what that one is. So the two answers, what are they? X equals 3 And x equals 7. Perfect. So a lot of times, I mean, you guys are really smart students here. A lot of times students are recognizing the pattern between these factors, right, which then generate these factors and these solutions, right? They're very similar. We have a -3. Our answer is going to be a +3. We have a -7. Our answer is going to be a +7. So you do have to be a little careful that you're not so lazy that you think that these factors go all the way to the answer. That's not true. The factors go into the factors, and then these factors are the opposite of the solution. So they are very related. You're going to find the pattern. You're going to get comfortable with the pattern, but don't rush your way through things. We're going to do 2 more of these questions. Let's look at number 6. And again, I'm going to move kind of fast. This is a trinomial factoring. We've got 1, 2, 3 equals 0. So we've got trinomial factoring. Very, very smart heads. We can't use the shortcut because we have a 2 here. But, and here's a big but, we need to consider this 2 is stopping us from doing the shortcut. Can we remove the 2? How are we going to remove the 2? What do you say? Division. That's actually, I like the way you've said that, but let's use factoring to do it. Mostly because we have a 2 and a 2 and a 2. We can divide all of these by 2. So you're right, Hazel. So let's do GCF. Let's take a 2 away from all of these. We take out the 2. We're going to be left over with x squared minus x minus 12. You're exactly right. Can't do anything with x's because this one doesn't have x's. So now we've taken out the 2. Now we can do trinomial here, and we can do the shortcut because we don't have a number in front of the x right here. So we're feeling good about that. 1 times -12 is -12, minus plus, 1 and 12, 2 and 6, 3 and 4. How are we going to make -1? Positive and negative, you're right. 3 and 4. Which ones, what are the signs there? 4 is going to be negative. X minus 4, x plus 3. So I agree with you there. Plus 3 minus 4, that's what we used. Well, let me ask you this question. Let me try to bust your brain a little bit here. I've told you that there should be 2 answers, right? Your highest exponent is how many answers you should have. We've got x squared, so we should have 2 answers. I told you that you're going to get 1 answer from each of your factors, right? Here's A, B, C. 3 factors. Are you going to get 3 answers? Let's see what happens. Let's just do it the long way, right? Let's take A, B, C, set all of them equal to 0, and see what happens. So taking my first one, A, equal to 0. My second one, B, equal to 0. And then the third one, equal to 0. So when we do all those, looking at the first one, right, this first one isn't even working for us, right? 2 equals 0. No. No, it's not. Quit lying to me, right? This does not work. This is not going to give us an answer. The answers come from the x's. Okay? Yeah? Yeah? Perfect. Okay, your answers are coming from the x's. And so if you don't have an x there, like for this one, then you're not going to get an answer. Really good job, you guys. Easy cruising on that answer. Let's do one more. Let's do number 8. And I think what happened last class is I need a little bit more room for number 8. Luckily for me, I can just erase this. A little bit harder for you guys to do that. So, looking at number 8. We need to do trinomial. Can we get rid of that 6? No. Bummer, right? We're stuck doing the long grouping factoring. So let's do it. Negative 24, which means minus plus. How are we going to make a 5 out of a negative 24? Is it 6 and 4? It's not 6 and 4. There's one other thing that makes 24. 8 and 3. That's what we need, right? To make 5? Plus 8 minus 3. Now, again, this is not able to go straight to the factors because we have this 6, and that has ruined it for us. So what we need to do is put 6x squared, and then we're going to take the 5 and split the 5 into these two numbers here. So it's going to be, oh, went a little bit too far back, minus 3x plus 8x minus 4. Okay, these two numbers are the same because they're not changing. The 5 is getting split into a minus 3 plus 8, which is still 5. I mean, this is still 5. It's just getting rewritten a little bit differently. Remember to put these x's here. A lot of times people forget these x's. All right, once we get this far, we need to split it down the middle. And once we split it down the middle, we're doing GCF. So we're looking on the left and thinking, what can we take out? What do you say, Hazel? 3x. And what is left over? 2x. And we have a 3x, but we took out 3x. Yep, we need that placeholder 1 to hang in there, and we'll be good. Now, when we go to the other side, we have to find 2x minus 1 as well. So what do we need to take out to leave behind 2x minus 1? 4. You guys are cruising. Like I said, when you're good at factoring, this is just seems like it's review almost. So really good job. Our two answers here for our factors would be 3x plus 4. That's the leftover stuff. And then 2x minus 1. That's the stuff they have in common. Now remember, we're not done yet. We still need to take each of them equal to 0. And that's going to bring its own little difficulty for us here. You're exactly right. We're going to have to divide. We're going to have to set this one equal to 0. 3x plus 4 equal to 0. And now we have a 4 that needs to get out of there and a 3 that needs to leave. So just like you said, we're going to subtract 4 first. We're going to get 3x equals negative 4. But we still need to move the 3 divided by 3. And so our answer is negative 4 divided by 3. Now, I know in Algebra 2, well, really in all math, we don't really like fractions, right? We say negative 4/3. Do I really have to do math with the fraction? Here's the good news. No, because you're done. Right? I mean, you don't have to actually do anything with the fraction. You don't have to add with the fraction. All you got to do is put a circle around it, you know? So don't let the fractions make you nervous because you're just going to write it and then leave it alone. Now, this other one, we still need our second answer here, and it's going to give us another answer as well, and it's going to give us another fraction as well. 2x minus 1 equals 0. Move the 1 to the other side. 2x equals 1. Move the 2 to the other side with division. X equals 1/2. And again, even if you don't like fractions, that's okay because you don't have to do anything with the fraction. You just leave it there, you're done. So the point I'll make with this question is as much as we were able to sit around before lunch and come up with these two answers 0 and -9, right? And that wasn't too bad. I feel like if I locked you in math class for a month and said, just guess until you find the right answers, I mean, you might have never found -4/3. I mean, that's a weird number to be trying out. So, don't feel like you can rely on yourself to just guess the answer, because some of these answers can be tough. And even if you guessed every number from -100 to +100, you still wouldn't have been the right answer because they happen to be fractions. So it's not hard to do if you're comfortable with fractions. With factoring. Now let's go over the back, and I want to look at two questions over here. The first one I want to look at is number 14. Okay. Number 14 is the first one we've seen where we do not have everything on one side. And so before we start this question, we need to get everything on one side. And so, do you want to move everything left or do you want to move everything right? I would disagree with you. I'd like to move everything left. Now, the reason we want to move everything left has to do with x squared. Okay? So remember, if we have x squared, we are allowed to do the shortcut, right? But Hazel, if we moved everything left, we would have -x squared, and then we would not be able to do the shortcut. So I always want x squared to be positive. As you can see, it's written on the board if you're in class. I always want, well, it's kind of hard to see in the dark with the green writing, but I always want x squared to be positive. So I'm moving everything left. That means I'm going to have to do a little subtracting of x. Make sure that gets subtracted from the other x's over here. Subtracting of x. I also need to subtract 4 from the other numbers. And so I've got x squared, 11x's minus another x would be 10x's. 29 minus 4 would be 25. And equals 0. Now we have to have 0 as our answer, because the only way we can use our strategy is if, a times b equals 0. So we cannot do this if we don't have 0. Now we get to do our factoring strategy, and this one's really easy. I'll go really fast here. 25, which is plus plus minus minus, 5 times 5. How are we going to make 10? 5, 5, right? X plus 5, x plus 5. So here's another thing that's kind of weird. What are our two answers? Our two answers are -5 and -5. Our two answer is actually the same answer twice, right? How weird would it be if I stuck you in the room and I was like, I need you to find two answers for me, and you found -5, and then you tried every number between, -1,000 and +1,000, and you're like, Mr. Collier, there's no second answer. And I was like, well, what about -5? And you're like, yeah, I already told you -5 was the answer. I'm like, no, but what about two -5s as your two different answers, right? It's definitely weird, but it's okay, okay? It can happen. Our two different answers are actually the same answer, which is a little weird. Now, let's go to number 11. Let's cross this out, because I want to give you guys a little bit of a harder question, because you guys are just killing it today. Let's do this one. X squared minus 6 equals 5x. Now, we're going to play a little game called Spot the Mistake, where I'm going to do the question here, and I'm going to make a mistake, and you've got to find the mistake, okay? So, first step, I need everything on one side. Oh, you didn't hardly let me get started. Okay, so I already made a mistake, you're saying? What do you mean, the way I moved? I mean, I think you're on the right track. What do you mean, though? Okay, I did a -5 and a -5. It's a -5. What do you mean? I think I moved this 5x over here correctly. The problem that I have is that these are out of order now, right? I've got x squareds, and then I've got no x's, and then I've got my x's over here. This is not the correct order things are supposed to be written in, okay? A lot of times people do that on these questions, okay? And they'll move the 5 and they'll just be a little lazy and they'll put it here. And as soon as you do that, you're going to get the question wrong. You have no chance to get it right, okay? Because you're going to do something like this, but it shouldn't be 1 times negative 5. It should be 1 times negative 6 because this is supposed to be behind the x's. So be a little careful. Make sure that this 5 is going to go in between the x squared and the negative 6. So I need the minus 5x right here, and then the minus 6. And then this question's really easy. Okay, I'll do a speed up because I think you guys know how to do this already. Minus plus, to make a negative 5, I'm going to need minus 6 plus 1. I can't choose minus 2, minus 3 because I need opposite signs. I'm going to get x plus 1, x minus 6 as my factors, and then my solutions are going to be kind of the opposite of that. X equals negative 1, x equals 6. All right, solving quadratics with factoring. That's it. Everything on one side, factor it, and then set it equal to 0, okay? That's pretty much it. Make sure your factoring is good. If your factoring is good, then you're going to be good at solving quadratics with factoring. Make sure, like on this question, you're putting things in the right order. But that's pretty much it. You guys did a great job, and that's pretty much it.